The most distant human-made object ever launched is NASA's Voyager 1 spacecraft, which has accomplished the unimaginable. It has crossed into interstellar space. Imagine launching a probe nearly half a century ago, with limited 1970s technology, and having it still operate far beyond its intended mission, exploring a cosmic realm that once existed only in theory. That's the astonishing reality of the Voyager mission, a bold endeavor that continues to redefine what we thought was possible in space exploration. What makes this even more fascinating is not just the distance Voyager 1 has traveled, but how it continues to communicate with Earth using hardware older than a cassette player. This spacecraft, launched in 1977, was built before the Internet existed and still sends back data across billions of kilometers of space. And now, more than 45 years since its journey began, Voyager has made a remarkable discovery, a revelation that has stunned the scientific community and captured attention across the globe. What exactly did this tiny machine, no bigger than a small car, find in the farthest reaches of space? And how does it reshape what we know about our place in the universe? To understand the Voyager story, we need to travel back in time to a key moment in history. In the early 1970s, NASA was preparing to explore the outer planets. It was the visionary work of Gary Flandreau, a brilliant engineer at NASA's Jet Propulsion Laboratory, that made this mission possible. With nothing more than calculations and a pencil, Flandreau discovered a rare cosmic alignment. The four gas giants, Jupiter, Saturn, Uranus, and Neptune, would align in a perfect configuration in the late 1970s and early 1980s. This event occurs only once every 176 years. If a spacecraft could be launched at the right time, it could use each planet's gravity as a slingshot, accelerating toward the next in a series of gravitational boosts, saving time, fuel, and money. This celestial shortcut, known as a gravity assist, reduced what would have been a 30-year journey to Neptune down to just 12 years. Faced with this once-in-a-lifetime opportunity, NASA moved quickly. In the summer of 1977, just 15 days apart, it launched two identical spacecraft, Voyager 1 and Voyager 2. Their primary goal was simple yet ambitious: closely observe Jupiter and Saturn and return data never before captured. But little did anyone know, these twin explorers would become the most successful and long-lasting missions in the history of spaceflight. Now, more than 4 decades later, both Voyager 1 and Voyager 2 are still operational and transmitting data from the outermost boundaries of our solar system. These spacecraft have far exceeded their expected lifespan. Originally designed for a 4-year mission, they have instead traveled more than 14 billion kilometers, reaching regions never imagined by their creators. Their achievements have rewritten textbooks, inspired new generations of scientists, and revealed jaw-dropping truths about the solar system. At the beginning of their epic journey, the Voyagers delivered astonishing close-up images of Jupiter's and Saturn's moons. What we once thought were cold, dead rocks turned out to be dynamic worlds filled with volcanic activity, icy geysers, and complex geology. Voyager 2 made history as the first spacecraft to fly by Uranus and Neptune, revealing their strange weather systems, magnetic fields, and enigmatic moons. These encounters opened a new chapter in planetary science, showing us that the outer solar system is far more active and mysterious than previously believed. To accomplish this, the Voyagers had to survive countless challenges. These spacecraft relied on less computing power than a modern digital watch. With just 69 kilobytes of memory, they had to store and process critical data using track tape recorders. Their main transmitter operated at only 23 watts, the equivalent of a light bulb, yet still managed to send signals billions of kilometers back to Earth. Their massive 12-foot satellite dishes helped transmit these faint signals using light-speed radio waves. Even so, as the probes drifted farther from Earth, gaining about 4 light seconds of distance per day, the signal strength became weaker. Today, a message from Voyager takes over 18 hours to reach Earth. This growing distance, combined with background noise from Earth's many devices, cell phones, radios, and satellites, makes it increasingly difficult to hear the spacecraft. Despite these challenges, NASA's Deep Space Network continues to listen carefully, like tuning into a whisper across the galaxy. Voyager's path took it first through the asteroid belt, a region filled with space rocks between Mars and Jupiter, a dangerous zone previously crossed only by Pioneer 10 and 11. Once it emerged, it continued on toward the outer planets, using their gravity to propel itself further outward. But its mission didn't end with Neptune. In 2012, something extraordinary happened. Voyager 1 became the first human-made object to enter interstellar space. This milestone occurred when the spacecraft crossed the heliopause, the invisible boundary where the sun's influence fades and interstellar space begins. Scientists once believed this boundary was about 50 astronomical units from the sun, but the actual crossing occurred at about 121 astronomical units. The team expected a dramatic shift, such as a sudden spike in cosmic rays, those high-energy particles from supernovae and black holes. However, Voyager didn't detect the abrupt changes they anticipated. Instead, it recorded a gradual increase in plasma density, a clue that confirmed its entrance into interstellar space. Curiously, there was no significant change in the magnetic field's direction, even though scientists had predicted that the solar and interstellar magnetic fields would be oriented differently. This lack of shift baffled researchers and hinted at a more complex boundary between solar and interstellar environments than previously believed. Beyond the heliopause lies the vast and mysterious Oort cloud, a theoretical region filled with icy objects and dormant comets. While it may take 30,000 years for the Voyager probes to reach this distant shell, their journey through interstellar space already offers groundbreaking insights. They are venturing into an environment shaped not by the sun, but by other stars, where radiation, particles, and magnetic fields flow from all corners of the galaxy. So what was the recent discovery that sent shockwaves through the scientific world? In 2023, Voyager 1 detected a persistent low-frequency hum, a plasma wave in the interstellar medium, evidence that even in the cold, dark, and lonely vastness between stars, space is not truly silent. This hum revealed an unexpected level of interstellar activity, possibly caused by energy interactions with ancient supernova remnants or the galactic magnetic field. This finding changes our view of interstellar space, from an empty void to a dynamic, vibrating environment teeming with energy. Voyager 1 and 2 are now time capsules of humanity, each carrying a golden record, a phonograph with sounds and images representing Earth's diversity, including greetings in 55 languages, music from different cultures, and images of life on our planet. These records are meant for any intelligent life that might one day find them, drifting silently among the stars. The legacy of the Voyager mission is more than its distance traveled. It represents the limitless curiosity of the human spirit and our enduring quest to explore the unknown. From Earth to the edge of the sun's reach, and now into interstellar space, Voyager reminds us that exploration is not just about distance, it's about discovery, wonder, and daring to ask questions that have no easy answers. Let us know your thoughts in the comments. What do you think Voyager will find next in the silent depths of space? And if you enjoyed this journey across the cosmos, be sure to like the video, subscribe, and join us here at Discovery at 2.0 as we continue to unlock the mysteries of the universe, one star at a time.